Hi, I'm Kelly Handerhan and welcome back to Session Wednesday. Today we're going to discuss certain types of symmetric algorithms. Another word for an algorithm is of course a cipher. So we're going to talk about block ciphers and stream ciphers. So when we look at symmetric algorithms, they fall in those two categories, stream or block. Now, stream ciphers are generally considered to be less secure but faster. And the reason they're considered less secure is that they're easier to reverse. Doesn't always equate to being less secure. You know, like anything, there are good implementations and poor implementations. But I want to show you what a stream cipher does, and then we'll look at how a block cipher operates. All right, now stream ciphers provide encryption 1 bit or 1 byte or 1 character at a time. Now, it's a very, very quick process. Boom, 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 boom. As a matter of fact, stream ciphers are often implemented in hardware encryptors because you need a device that can just spit out those ones and zeros as quickly as possible. Some of the ways that stream ciphers can encrypt is they can do substitution of one character for another, transposition, scrambling the text. But another common process that many stream ciphers use is a mechanism called XOR. Exclusive OR. All right, and the way exclusive OR, and again, keep in mind we're encrypting 1 bit at a time. So the way the XOR process works is like this. Let's say I have some plain text, okay, and just a series of ones and zeros, nothing special about what I'm writing up here, just making them up. All right, and then I'm going to have what we refer to as a key stream. Again, the key stream should be randomly generated, so just making things up. But the process of XOR is matching up a bit in the plain and a bit with the key. And if the values are like, the ciphertext becomes 0. If the values are unlike, different, then the ciphertext becomes 1. So, in this instance, what is the ciphertext? Well, 0 and 1 are unlike. They're not the same. 1 and 0, unlike, not the same. 1 and 1. Are the same. Okay, and that becomes my ciphertext. Now what you can see is that's very quick and easy, right? Boom, 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 boom. Just like if I have the key stream, it's very quick to reverse. Stream ciphers, one of the better known stream ciphers is RC4, and RC4 was a cipher that WEP and WPA used as part of, for their algorithm for wireless encryption. Now again, good speed, but not necessarily great security, especially the way RC4 was implemented in WEP. It was implemented very poorly. You know, that's a totally different discussion. So that's stream cipher. Now a block cipher is more complex. It's considered to be more secure, but it does take longer. It takes more overhead, it's more difficult to reverse. I've mentioned to anybody that's seen my earlier versions of the Sessions videos, I am from North Carolina, and I am a proud product of the North Carolina public school system. 49th in the nation, baby. And our state motto being, we're not South Carolina. Small favors. All right, so out of 12 years in the North Carolina public school system, this is all the math I learned. Okay, I can take any number and add 2, I can take any number and subtract 2, multiply by 2, divide by 2, I can take the square root of, I can raise to the power of 2, that's it. That's all the math that I know. This is Kelly's algorithm, Kelly's cipher. And this is a block cipher. So what happens with Kelly's cipher is data is chunked into blocks, hence the name block cipher. The block may be 64 bits, maybe 128-bit, 256-bit. Every algorithm uses a different block size, but they all essentially work the same. So the block, data is chunked into the same size block. Each block goes through a series of math functions. Again, everything comes down to numbers. Everything comes down to ones and zeros. And actually, these functions are actually referred to as S boxes, substitution boxes, because at each math function, some sort of substitution happens based on the math. So this block goes to function 1, then it goes to function 4, then 5, then 2, then 3, then 6. And for each one of these functions, math occurs, substitution happens. Now, which math functions are used, and what order, and how many? All of that's determined by the key, right? The key provides the instructions on how to use the math or which S boxes are called. So in short, block ciphers, there's a lot more math going on. There's a lot higher degree of complexity. They have a lot more overhead, but they are more difficult to reverse. So a quick review. Stream ciphers, 1 bit at a time. They can use substitution, transposition, permutations. I don't know that I mentioned that, but number of rounds. So if you do something once, twice, 3 times, 4 times, you're putting it through various permutations. But a common means that stream ciphers use, the XOR process. Block ciphers, on the other hand, are going to chunk data into blocks, put them through a series of math functions as determined by the key. Common block ciphers. AES right now is the de facto standard. It's what the government uses for their controlled but unclassified information. That's what most applications default to. Other block ciphers you may be familiar with, triple DES, IDEA, which is one that PGP, that came out with the PGP, the mail, proprietary mail application. So I think you'll see a lot more block ciphers in use today than you will stream ciphers. I mentioned WEP and WPA used RC4, which was a stream cipher. The successor to WPA, WPA2, shifted over to the more complex block cipher and uses AES. Hope this was helpful to you, and we'll see you next week on Session Wednesday.